Okay. This is your answer, right? You already run regression. And now I asked you that how to interpret all of the coefficients. Right? I asked you to report in standard table form and then interpret all of the estimators or interpret all the coefficients that you got. Okay, so I'm going to write it down. We have vote A here, right? And then you have beta 0, beta 1 of the expenditure A plus beta 2, the expenditure B, and then the last one, the last one is your beta 3 party A. So I'm going to write it in short, okay? But it's going to be exactly the same as I already showed you on PowerPoint. And again, you already got beta 1 is around like minus 6.6 and beta 2 is like 6.08 and beta 3 is 0.15. And for vote A, the unit is in percentage, right? This one is in dollar. This one is also in dollar, also in percentage. Okay, and then I already told you that even though your variable has a unit of dollar, but once you take natural log in there, you already transform that unit. So any variables that you already take natural log will not have a unit. Okay. If you still remember, like, if you would like to interpret your beta 1 here, it will be like a level log model for beta 1 and beta 2. For both of them, if you would like to interpret it. Right? It means that you have to divide beta 1 or beta 2 with 100, right, to interpret the coefficient. For example, like if the expenditure, right, if the expenditure A increases by 1%, right, because you already take natural log in there, so it will be like a percent. So if the expenditure A increases by 1%, how is that going to affect vote A? So it will be like this one, right? And actually, because you have a minus here, it means that if the expenditure A increases, vote A will decrease. And vote A will decrease in percentage in this case because it's already a unit of vote A. Are you confused? Do you have any question about it? So it's exactly the same for beta 2. So for your beta 2, you still have to divide your beta 2 with 100, right? It means that if the expenditure B increases by 1%, your vote A will increase. How is that? It's like 0.6, yeah, 0.6% for vote A. Right? So that is how you interpret beta 1 and beta 2. But how about beta 3? For beta 3 here is like a level model. Because you did not do anything with the beta 3, you did not do anything with the variable party A, right? But fortunately, you already have the unit of party A as percentage. It means that you can use beta 3 to interpret it. So if the party A, for example, like I cannot remember what is this variable. So if the party A increases by 1%, vote A will increase by 0.15%. Because we can interpret it as percentage if your variable already has that unit. That's why, like, normally we don't take natural log to any variables that already have a percentage unit because it doesn't make sense at all. You don't have to take natural log, but you can still interpret it as percentage. Okay, so please be careful with that, okay? So first, when you would like to interpret your results, you have to take a look at the unit of the variable that you are using. So I will show you. I remember I was in the Tuesday class, in your lecture class, and I heard that Ngọc already asked some question, which is, it was very interesting question. And this is about how you interpret the results as well, which I will give you some examples today. Do you have any question about how to interpret the different units of your variable here?
อาจารย์ครับ
Huh?
What if it is and ln in both sides ครับ
Oh, good question. So if you have, for example, like if you have ln vote A, beta 2 plus beta 1 ln expenditure A, right? In this case, if I assume that vote A is not in percentage anymore, right? It can be like, for example, like score or any points to party A, for example, is not in percentage anymore. Okay, so if you take natural log in both sides, it will be like a log model. So in this case, you will interpret it as like an elasticity. So an increase in expenditure, a 1% increase in expenditure A is going to increase vote A, like how many percentage in vote A. For example, like if your beta 1 is 0.6, for example, it means that a 1% increase in expenditure A, right, will increase vote A by 0.06%. And again, you can use beta 1 to interpret your result. You don't have to do anything with it. So actually, like log model, like the way you interpret log model is the same as the way you interpret like beta 3 here. But beta 3 here is like you did not change any, you did not take log into it, right? You did not take natural log into it. But the variable already has a unit as percentage. So that's why you can use beta 3 to interpret as like elasticity. But you don't have to take natural log into it. Does it make sense? Do you have any question?
อาจารย์ครับ another question ครับ
ค่ะ
if I multiply the constant to the variable when I want to interpret it, do I have to divide it out or not?
What do you mean by you would like to multiply a constant term? So
Yeah,
for example,
for example, I have an HDI, and then the value is not near for the other variable, so I just time by 10 to make it to be more nearing.
Okay, I see your point. For example, like if you have wish here, and then you would like to know that how is that a relationship with the education, for example. But wish here, you know that the education you have just only like, I think like the highest one will be just 1 to 20 years of education, right? I think like 20 years of education is like the highest one that normally people can have it. But wish here, you can have it from like $1 or $1 until like $1 billion, for example, which you have a very wide range of your number, right? And sometimes because your independent variable has like a very low value, when you run regression, you will have like, for example, you have a very kind of like long decimal or something like that in your results. The thing is that I recommend you to do something like your friend asked me. You can just multiply it with a constant to change your unit. For example, like if your for your observation 1, 2, 3, they might have like $1,000, and then another one will have like a $10,000, and another one will be like 50,000 US dollar. And you think that okay, the number here is kind of like pretty big if you compare it to your dependent variable. Your independent variable. Maybe you can just divide it by 1,000. So here for the first observation will be 1, and then the second will be 10, and the third one will be 50 because you already divided by 1,000. Right? You already kind of like transform the unit of it. So here it will be just dollar. But once you multiply it with 1,000, this one will be like $1,000 instead. It will be the unit of it. So how to interpret this one if you got your results already? For example, if your beta 1 is equal to 1, for example, it means that education increases by 1 year will increase wage by $1,000 because you already transformed the unit of it from dollar to $1,000. Your beta 1 is equal to 1, but the way you interpret is equal to increase by $1,000. Did I answer your question, Chanarong?
Yes ครับขอบคุณครับ
Yeah, I mean, like you can do it. You can transform your variable. If they have like different values, like different numbers, you can do that. You can multiply or divide with the constant term, but you have to be careful when you interpret your result.
Professor, may I ask a question?
Sure.
So, this is with the log form again. So, like the whole class, I've been thinking that okay, if like we need to interpret it into percentage, right? Then it means that the form of the independent variable it would be in ln. But then now that you say that is if it's percentage anyways, then we don't need to put in ln form. So I would like to ask, how do we know if it's ln form?
What do you mean by that? You mean like if you download the data set and if you can see that it's already percentage, how can you know that it's like a real percentage or in ln form? Is that your question?
No, it's more of like, how do we know when should we put the ln or like the log into our model?
Okay. That's a good question. So first, I already told you at the beginning of the class, like, okay, before your midterm, if you like to put natural log form into any variables, you have to think about the way you interpret it, right? If you feel like, okay, if you interpret it as percentage and like your result, your interpretation is not weird to interpret it as percentage change, go ahead, do it. But for the question that Ngok already asked, I mean, like if you already have like your variable already in percentage, you don't have to put natural log form. So it's going to be like a vote A and like a party A, right? You don't have to put in it. You have to put natural log form into it because they already have percentage unit. But any variables that do not have percentage unit, you can put natural log form into it. But you have to think about the way you interpret it. Does it make sense now?
All right, thank you.
Okay. I mean, like if you still have some more question about it, just you can ask me after the class. Okay. Any question? Okay, if you don't have any questions, we will go to our today's session. Please download the data set I already posted on Google Classroom. So today we are going to talk about dummy variable. And again, I'm going to start with the e-views first, and if I have some time left, I will show you in Excel. Please import your file, the data set that I already posted. Okay, and then I would like you to run regression with this model. Okay, let me type it in. Okay, so your dependent variable here will be wage, and you know that wage is like is in dollar term, right? And then your first independent variable will be education. The second one will be black. So after you finish downloading the dataset and already import it into your eViews, please run this regression. So your dependent variable here will be wage in dollar terms, in dollar unit. And then your independent variables will be education. Please be careful. I remember there are two education, so we are going to use just the education without two, just education, okay? And then another variable here will be black. Okay, so I'm going to do that. Is the education and black, right? And then do right click, go to open, and then as equation. Then click OK. This is your result, right? I would like you to answer my question. Interpret all of your coefficients that you have. So you have two coefficients here, one for education and another one is for black. I will write it down here. So for the education, and also education is years of education. So the unit is years. And then black here is a dummy variable. Equal to 1 if an individual is black. So answer my question, just interpret your coefficients. It's in dollar unit, so which one is kind of like just a normal variable here. And education, we use this all the time, is the number of years of education. And then black is a dummy variable. So black will be equal to 1 if an individual that we collect data is black, and will equal to 0 if an individual is white person. Okay, I think this one is easy for all of you, right? We always do it. For education, so you will see that the coefficient is equal to 55, like approximately just 55. So the way you interpret it is that if an education increases by 1 year, wage of individual will increase by $55, right? We already used the unit of our variables. Our wage is dollar unit and education is years, in years. So if education increases by 1 year, wage will increase by $55. But how about black? Since black is dummy, how will you interpret it? How did you interpret it? Oh, I'm sorry. You asked me like, is wage 3 different from wage 2? Yeah, it's different. You cannot download it. I see. For Felix, maybe you can just use wage 2 instead. I mean, like some variables will be different, but for like education and black, that will be the same as in wage 2. Maybe you can use wage 2. Yes, exactly, Knock. Your answer is correct. Yeah. If you are not a white person, like you are black person, your wage will be decreased by $189. Exactly. So this is the data set in the United States. So if you are not familiar with it, in the United States, they are like very their environment is very diverse. They have different people like a color, like people of color, like black people, and they also have white and also have like Hispanic. The people who moved from different countries who are not a native, like not American, something like that. And basically, we used these different races to calculate the different wage that they will get as well. And normally, because black people and Hispanic people, they are more likely to have lower education. So that's why they are more likely to have a lower wage as well. So that's the labor market in the United States. And yes, from the result, you will see that the black people or like people of color, they have like a lower wage as the assumption as we expected before, right? But one thing that I would like to show you is that if you would like to plot a graph between expected wage and the education, but you would like to show the differential between black and white people, how can you do that in eViews? Okay, so I think you're already done with the interpretation. And first, since we have two variables here, right, and we would like to plot a graph between wage and the education, and we would like to see the differences between the differential between black and white people. So first, I'm going to predict wage by the results that we already got. So just go to proc. So in the window of the results, just go to proc at the top of it. And then go to forecast. just click it. And then they will ask you the series name that you would like to name your new variable here. So they already set default, like it's going to be your dependent variable name followed by F. So F here, I think is like a in charge of the forecast. So if you don't want to change it, just let it there. It's a default. And then just click OK. So they will give you like a plot chart here, which actually we don't use it. If you would like, don't be shocked, okay, don't be panicked. You still have the regression result. Just go back to view and then go to estimation output. They will go back to your regression result. And then just take a look at your variable window. They already give you a new one. It's the weight F that you already generated. Just double click on it. So compare the number of the observations that we have is 935, right? You will see that once you forecast this or you already predict weight, you also have the 935 observations here. It means that once you use forecast, they are going to use the coefficient here, plus they will use the observation characteristic that you already have the data, and you just plug it into your regression result, and they will predict the weight of each individual. So now we already have the predicted weight from our regression. And I already told you that I would like to plot a graph between weight and education, right? So we are going to open it as a group. So first, I recommend you to just click on education, because the order of the variable that you choose will affect the graph that you are going to plot, okay? So let me click on the education first. So education here will be your independent variable, right? Because your education changes will affect weight. So I'm going to click on education and then click the weight that you already predicted. And again, just open it as group. And again, we will go to view. At the top of the spreadsheet, go to view. And then go to graph. We already did it before, right? So once you click on graph, you will get another window. So normally we will use scatter, right? We will not do anything about this window. Just click on the graph that you would like to plot. But this time, we are trying to separate a graph between black and white people. So you will see that on the top of it, they have a basic graph, right? Like a graph type, general, and they also have a basic graph here. Just click on it. And then choose categorical graph. they're still almost the same. If you can notice that they have many graph types that you can pick on compared to this one, almost the same thing. But why do we need categorical graph? Because normally if you use just scatter, they will plot just only two variables in there, right? For example, if you like to plot between education and race, you can do just only like one line, because normally we will have fit line. They will not separate our data set. They will just combine all of 935 observations for us. But if we click on the categorical graph, it means that we are trying to separate the data set into any variables that we would like to study. So I will show you, okay? Just follow me. So this time we are going to use scatter again. Once you click on categorical graph, just go to scatter. And then, again, we are going to have a regression line. For your fit lines here, just go to regression line. And now you will see that they will ask you which factors you would like to define it as category, right? And in this case, I already told you, I would like to see a graph between black and white people. So the variable that I would like to use is black. And because we are going to plot a graph of with an education together in one graph, but we would like eViews to separate the data set between black and white people. So in this case, we are going to use within graph. Once you're done, just click OK. This is exactly the same as you learned in your lecture, right? You will see that we have two separate lines, right? The orange line here below one is for black people, and the blue line is for white people, because the blue line black is equal to 0. It means that they are not black people, right? Okay, so let me show you in theory. So in your regression, you regress based on education and race. Right? Oops. And in your lecture, you learn that so if your observation is black, right? Black is equal to 1. It means that once you are trying to predict that wage, there will be beta 0 plus beta 2, right? This will go to your intercept, and then you will have beta 1 times with your education here. But for non-black people, your dummy here will equal to 0. It means that your intercept will equal to beta 0 plus beta 1 times with the education variable here. And from our result, beta 2 here is negative. right? Our beta 1 is equal to, I'm sorry, beta 0 is equal to 41 roughly, and beta 1 here is equal to 55, and then beta 2 is equal to 189. It means that for Black people, your intercept will equal to 241, I'm sorry, minus with 189, right? But for non-Black, the intercept will equal to 241, right? So that's why when you plot a graph between Black and non-Black people, you will see that the intercept of non-Black will be higher than Black people. It's exactly the same when you did it in eViews. Do you have any questions? Okay, so if you don't have any questions, I would like to do something more complicated. So now you already added a dummy variable, right? I would like to show you how you interact dummy variables together. So if you take a look at your data set, we have Black as our dummy variable, and I would like to see that if non-white, okay, non-white people live in South, how is that going to affect their wage? So I'm going to just interact this dummy variable with South dummy variable. And again, I'm going to use command window at the top to generate our interaction term. So I'm going to use series. And then just type any variable name that you would like to use. Just name your new variable. So I'm going to just use this Black underscore South just to let myself know that, okay, this variable, I interact Black with the South variable. And then use equal. So interaction term here is just you multiply two variables or more than two variables together. Right? So in this case, if I would like to interact between Black and South, it means that I am going to multiply Black dummy variable with the South one. And again, in eViews, if you would like to multiply something, you are going to use like a star sign. It's the same as in Excel. So if you cannot see it, this is the command that I use. Just type series and then type any variable names that you would like to use, and then use equal sign and then type Black, put star sign as like a to show that you like to multiply with another variable here, and then type south. Okay, so once you finish generating your interaction term, I would like you to run regression, this equation. So we just add another new variable here and another interaction term that we already generated. Okay, so I guess you're done. So it's going to be request range on like education. Oh no. Like education, and then what else? South, and then black south. Okay. So print as equation, right? This is going to be your result. And again, so once you're done, I would like you to interpret all of the coefficients that you got. Okay, so from your lecture, I think you can remember that if you have two dummy variables, right, you can kind of like separate into different cases. So in this case, you will see that we have two dummy variables here, like for non-white people and also like for people who living in south part of the United States, right? So you can generate different cases. So it can be like if they are black people and also live in south, so like non-black but live in south, or be like black but not living in south, and also non-black and also not living in south. It means that you can generate into 4 different cases. Right? But anyway, you will see that both of black and south, and also even though like the interaction term here also like negative, it means that if they are black, they are more likely to have lower wage. And also if the person who live in south part of the United States, they are also more likely to have a lower wage. And if they are both black or living in south, you can see that they will even more have like even more lower wage. And again, so in the United States, most of non-white people, they are more likely to live in south part of the United States. So that's why our result just tell us that, okay, most of non-white people, they are more likely to have lower wage, and if they are living in south, they will have like a much more lower wage than any other people living in different parts of the United States. So talking about this, I'm not pretty sure that you can remember what you have learned in class. So if you have dummy variable, basically you will have base group or reference group to interpret your result, right? So in this case, for example, like for beta 1, so black here is equal to 1 and 0, right? So normally like the reference group will be 0. So if you remember, like if black is equal to 1, it means that that individual is black, right? And if this dummy variable is equal to 0, it means that an individual is white person. So our reference group here is white person, like white people. So if your beta 1 is minus, for example, like in this case, black is minus 74, it means that black people will have lower wage than white people. So you have to compare your result with the reference group. And also the same, because like south dummy variable here is also minus, and it's equal to minus 63. It means that people who are living in south part of the United States, they are more likely to have lower wage than people who live in different, like any other parts of the United States. And again, I'm going to show you how to generate a graph if you would like to see like you plot a graph in different cases, right? And based on I told you we have 4 different cases for this one, right? Just go back to your e-views. And then again, we are going to forecast our dependent variable. So from here, just go to proc, and again, use forecast. Because we already used wage F, right? In this case, I'm going to use wage F2. Just put 2 in there. Otherwise, that will be the same name, and eViews will not generate another variable for you. So once you're done, just click OK. And again, just click on weight F2. You will see that they already predict weight based on the characteristic of the individuals that you collected data. Right? And then I'm going to plot a graph between weight and education again. So I'm going to just click on education first and then click on weight F2. Just open it as group. So basically we are going to repeat our step. Just go to view and then go to graph. And again, because we are trying to separate into different cases between Black and non-Black, people who are living in South and not and living in other parts of the United States, we are going to go. We are going to use categorical graph again, and use scatter again. We are going to use fit line as regression line. If you remember, like our previous graph, I used just only one variable, right, to tell eViews that I'm going to separate our data set into for non-white and white people. But in this case, I'm going to use two variables at the same time. I'm going to use Black and also South. Because we have two dummies right now. Right? So once you're done, click OK. This is exactly what we talked about, right? So you see that they are, like eViews already separated into, separate our data set into 4 different cases. They also have people who are non-white, people living in any other areas, people who are non-white people, Black is equal to 0 is white people, So white people living in any other parts of the United States, white people who live in South, and also like non-white people living in any other parts, and non-white people living in South. Right? And if you take a look at the graph, you will see that, okay, so non-white people who live in South will have the lowest intercept. Right? They are more likely to have lower weight. And how to interpret it? For example, like if you fix education. So if you are considering education at 10 years, like 10 years of education, right? You will see that non-white people who living in South will have the lowest wage compared to any other groups. This is how you can kind of like see the results from plotting a graph. You just have to fix your independent variable, right? So you might fix at the 10 years of education or maybe 12 years of education. You will say that anyway, any education, like any number of years of education, people who are non-white and living in South will have the lowest wage. So in this case, if you generate interaction term between dummy variables, the slope of the graph will not change, right? So I would like you to run another regression. If now I would like to interact between non-white people and the education. So you have to generate another interaction term between black and education. And please run this regression. So we are going to use the same command, right? But change from black South to black education. And is going to be equal to black multiplied with the education level, right? And then I'm going to regress wage on the black education and also black, the interaction term between two of them. And this will be your result. And again, I'm going to just forecast wage. Just use forecast again. Just go to proc and then use forecast. And then I'm going to name it as wage F3. Click OK. And just repeat the same step. I would like to plot a graph between education and wage. Just open it as group. And please be careful when you select your predicted wage, okay? This time we are going to use wage F3 or any other names that you already used it, I'm not pretty sure. So in my case, it's going to be the latest predicted wage, and I'm going to plot it with the education. Again, going to graph, and we are still use the categorical graph, use scatter, and again, I would like to separate my data set between white and non-white people. So once you're done, just click OK. So now you will see that. So normally, like our previous graphs, the slope will exactly the same, right? But we will see like the different intercepts. But in this case, we will see different slope. So the blue circle line, the blue circle one is for white people, and the orange one will equal to the non-white people or black people. So from the graph, you can see that the higher education, the wider gap between wage of black and non-black people, right? So for here, like for example, like if the education is equal to 10 years, they have like a very narrow gap between these two groups of people. But once you have a higher education from 10 to 12, from 12 to 14, 16, and 18, you see that like the gap of wage between these two groups of people will become wider. This is another way that maybe like you can just plot a graph, right? And you can see like the trend of your data set, the trend of the data. And you can see like how your data changes between these two variables that you are interested in. Okay, so let's see our equation a little bit. So the equation that I asked you to do is wage on beta 0, beta 1, black, beta 2 education, plus beta 3 is the interaction term between black and education, right? So normally if you would like to see how the education change will affect your wage, you just take derivative, right? Partial derivative between wage and with respect to the education, right? And from the regression, from the equation that we have, you will get the beta 2, right? Because you have education here, and you also have the education in your last term. And you will have black variable in there. Do you have any question about it? So we just take derivative of which with respect to the education level, right? It means that if the education changes, it also depends on the race of the individual, right? If black is equal to 1, if you are non-white people, it means that your change will equal to beta 2 plus beta 3. But if you are white people, your result will be just beta 2. And from here, you will see that the differential, right, between black and non-black people is equal to beta 2 plus beta 3 minus beta 2, right? This is equal to just beta 3. So from this equation, from the equation that you already do regression, right? You will see that if the education changes and you would like to see the differential between races, you just take a look at your beta 3. So beta 3 is the differential between black and non-black people if you keep the education constant. Sounds good. Do you have any question? Okay, and now I would like to talk a little bit about the types of the variables. So I remember Ngok asked Dr. Sivapong in class, right, about if you have one variable which is equal to, like, for example, like 1, 2, 3, 4, 5, it's not just a dummy. So dummy here is the value of the dummy variable will be equal to 1 or 0, right? But if you have 1, 2, 3, 4, 5, for example, like it's just the level of your satisfaction. If you remember, like we have a Likert scale, right? One, two, three, four, five. If you have less satisfaction, and you have like more satisfaction here, something like that. So if you have just like 1, 2, 3, 4, 5, or something like this, how can you interpret it? And I remember like Dr. Sivapong already told in class that you just kind of like interpret it as normal, like as you already did before. For example, like in this case, if you take a look at the data set that I already gave you, so you have two types of education here, right? I will explain you later. But one thing I would like to show you is that there are four categories. There are four categories of variable. So the first thing is the nominal variable. The second one is ordinal. Interval, and the last one is ratio. So for nominal here is like you cannot compare anything. For example, like gender. You cannot say anything about female and male, right? You cannot compare like, okay, female is better than male or male is better than female. You cannot say anything about gender. So normally here we just create dummy in your equation, right? So female is equal to 1 or male is equal to 0 or something like that. But another one is like an ordinal. For example, like you might have education. But education here is not a number of years of education. So normally, like in data set that I gave you, is the years of education, right? So that's one we called it as a ratio variable. So ratio variables here will be like, okay, you can compare between two groups and you can say like how much they're different. For example, like in this case, you know that if you have two persons, like person 1 and person 2, and you know that person 1 have a 10 years of education and person 2 have 12 years of education, you can say that person 2 has higher education than person 1, and you can compare that they have 2 years higher than person 1. This is the ratio, or maybe like age. Like I can say that I am older than all of you, and I can say that, oh, maybe like I am 10 years older than all of you. So you can see that, okay, you can compare between two groups, between two items, between two things, and you know that how much they're different. But for ordinal, you know that it's higher, but you cannot say how much they are different. You cannot say how many years they are different. You cannot say like how bigger they are different, for example. Like in the ordinal case, maybe like grade of education. So in your questionnaire, you might say like, okay, you have people from grade 1 to 6, something like that. And you also have college level. So for people who have grade 1, 2, 3, 4, 5, 6. You know that people who can study at grade 4 has to pass grade 3 already. So people who study in grade 4 will have a higher education than people who are studying in grade 3. But you cannot say like how many years they are different. You can compare like, okay, this one is higher, this one is lower, but you cannot say like, you cannot compare it, like you cannot say the amount that they are different. So that is the characteristic of ordinal variable. And for interval, let me give you some example. For example, like income. So for ratio, if I have $10,000 and you have $1,000 for your income, right? I can tell you that, okay, I have higher income than you, and I know the amount that I earned, and it is different from how much you earn. We can say exactly the amount, right? But for interval, you might have, I think you might see it in some questionnaire. For example, like from 1 to 100, from 101 to 200, from 201 to 300, something like that. For example, like this is your income range. This is the interval variable. For example, like if I have this income, and if you guys have these incomes, so you can say that, okay, you guys have higher income than me, but you cannot say exactly how much you can earn and how much that is higher than my income, because it's an interval, right? So person A will be like this, or maybe like in this range. We cannot know exactly how much they can earn, but their income falls in this range. This is how the how the interval variable looks like. Do you have any question? So we have, like, there are 4 different categories of variable. Nominal, you cannot compare anything. Ordinal, so both of them are still like qualitative data. So ordinal is like, okay, you can compare, but you cannot say anything like how much they are different. For interval, it's like a quantitative already for this one, for these 2 quantitative, for these 2 types, because they ask them like all the number, right? But it's in interval, it's in range. It means like which one is higher, but you cannot say exactly how much they are different. And the last one is the ratio. Ratio is just like the number. You can say you can conclude anything from this number. If you have higher income, how much you have higher income than me, for example. So let's go back to the sample. Just go to your e-views. So now I would like to run regression. I would like to regress based on the education tool. and also black. Just open it as equation. So I already used different education variables. So if you just open both education variables together as group, you will see that I have different types of variable. So the education, you already used it. The first one is a racial variable. I already collected like how many years they already have education. They are already in education, right? And then for the education to the variable, another variable here, I already transform it from years to kind of like ordinal. It as one, for example. And then I know that if they have higher education, the level of it will be higher. So in this case, I cannot remember exactly. I set them like, if they have less than 10 years, the education to will equal to 1. And then if they have education between 11 years to 13 years, I will set it as 2, something like that. So once you run regression, how can you interpret the coefficient of education here? For example, like if we use just the education, the number of years of education, if the better one is equal to 155, you can conclude that a 1 year increase in education right? You are saying that a 1 year increase in education, but in this case, our education variable is different. I use gamma 1, 0, gamma 1 plus the education 2 here, right? And our gamma 1 here is equal to 190, 132, I'm sorry. So you can say that if one level you can say that an increase in education by one level, which will increase by 132 US dollar. This is how you interpret it. It will be different between two types of education variables. You will say that for the first one is the ratio. That unit is years, right? How many years you are in education? How many years you have education? But in this case, for the second case, you just set it as level. Right? You have different level, 1, 2, 3. So the way you interpret it is going to be different. You cannot say it increased by 1 year anymore. You have to change it to one level. If the education level increases by 1 year, how is that going to affect your wage? Make sense? Do you have any question? it might be a little confusing, but please be careful when you interpret your result. And some of you might have a question like, oh, if we would like to generate dummy variable, or if you would like to generate something like the education that I am showing you right now, how should we set like which one should be our reference group or which one should be our base group or something like that? So I just recommend you that if you have, for example, like for gender, if you have female and male, it should be fine, right? Because if you set female is equal to 1, male will be equal to 0 automatically. But if you have more than 2 genders, for example, like if you have female, male, and also others, you have to ask yourself which one would be better based on your research question. For example, like if you are talking about wage, and if you think that male will get the highest wage, right? You might set male as 0. Oh, I'm sorry, I cannot do this one. I'm sorry. I cannot use gender for this case because this one is the nominal one. You have to generate dummy anyway. But one thing that you might be confused is about the ordinal. For example, like the education, you might have grade 12, I guess, college, and higher than college. For example, like master degree or PhD, something like that. So you have different levels of education, like 3 different levels of education, and you would like to say something about which. And then you think that, okay, higher college should have the highest wage. So you might say, oh, I cannot use this one as well. I'm sorry. It should be nominal. Oh my God. I think like our previous example should be fine. So I would like to say something about female, male, and other. I'm sorry. And you would like to say something about wage, and you know that male would get the highest wage, right? And you know that because this one is the nominal. And from the lecture, Dr. Sivapong already told you that you cannot put all 3 dummies together in one equation, right? For example, if you said email is equal to 1, so 0 will be any other genders, right? The same as male and also other. Like male will be equal to 1, and if any other genders will equal to 0, right? And in this case, you might have a question like, okay, if we have different 3 dummies here, so which one should be our reference group? Because you have to drop out 1 dummy, right? Because you cannot put any dummies within the same equation. Otherwise, you have a multicollinearity, perfect multicollinearity. Okay, so you have to drop out 1. So which one should be our reference group? The one that you drop out will be your reference group, right? So I recommend you like maybe you just think about the highest one. So in this case, if you just drop male out, right? Just use male as your reference groups. You will be that your equation will be with beta 0, beta 1, and then female, and then plus beta 2, and then others here. So if your beta 1 is minus, you can say that female has lower weight compared to male. And also for beta 2, if you get minus, you can say that, okay, because other any genders will get lower weight than male. Or maybe if you think that female will get the lowest weight, so the way you are trying to omit one variable out of your model, you have to think about the highest one or the lowest one. So I think it would be easier for all of you to, just to interpret your coefficient. So in this case, if you drop out the female, you will get beta 1 male and beta 2 others instead, right? And then if beta 1 is positive, you can say that, okay, male has like a higher weight than female. Or maybe like north, south, east, west, and you think about west. You might think like, okay, north, people living in north are more likely to have the highest weight. And in west will get the lowest one, for example. So you can either drop north or west, depends on your preference. So it will make your coefficients interpret easier. Do you have any question? And for the e-views, if you just put all of the dummy variables together and it caused the multicollinearity, like the perfect multicollinearity. I remember I showed you last time. They will not give you the result for the e-views. For example, like in this case, if I would like to regress weight on east, north, and south part of the United States, right? And also maybe like, okay, just include age here. If you would like to regress it, they will not give you any results because they say your model has a problem of the perfect multicollinearity here. Okay, it means that you have to adjust your model. And I can see as well how would we interpret the ordinal variable in regression. Okay, so as I mentioned before, like for example, like the education. So instead of interpreted as increasing in 1 year, it's going to be like increase like in one level of education. Does that make sense? Or maybe like there is another sample that I can give you. Yep. Okay, another example, like the Likert scale that I told you before, right? You have less satisfaction, for example. And you have so, right? I don't know how to say it, and then more satisfaction. and then you set it as like less satisfaction here will be equal to 1, and then so is 2, and more satisfaction is 3. Once you run regression, right? For example, if you have tips, so tips of the server in one restaurant, right, depends on the satisfaction of customer, for example, and this one is the satisfaction level. So if the better one is positive, it means that once the satisfaction increases by 1 level, how is that going to affect the tips of the server in this restaurant, for example? This is the way you interpret the ordinal variable here. Okay, do you still have any questions left? I know all of you are tired already. Okay, for today, I think it's a good news because you don't have to turn in any in-class assignment, okay? I just want you to practice how to generate like graphs from e-views or something like that, how to use the command to generate the dummy variable or interaction terms. Okay. Yeah, you don't have to turn in any in-class assignment.
อาจารย์ครับ
Huh?
Is it okay ครับ if our project don't have dummy variable?
It's okay. You don't have to.
โอเคครับ
Okay, any questions before I let you go? Okay, so if you don't have any question, we will see each other again next week. And please stay tuned. I'm not pretty sure about the presentation schedule, but I will update you as soon as possible.
อาจารย์ครับ
Huh?
คือผมมีเรื่องสอบถามเนี่ยคือผมทำเรื่องเกี่ยวกับที่มันตัวแปรที่มันจะเอฟเฟกต์กับอีโคโนมิกครับ